Hello and welcome to How to Code in JW Lua episode number 4. Now today we're going to be learning best coding practices and specifically how to make sure that you actually are writing real good code and not just sloppy thrown together code. Now before I continue any farther, I just want to say thank you to Yari Williams for creating such a valuable resource, JW Lua. I realized I might have not thanked him before until this episode, and I really want to give him the credit that is due. So thank you, Yari. And so back on topic, why are we talking about best coding practices when all we want to do is learn JW Lua? Well, it comes from a bit of a conundrum about this series with JW Lua because we're really trying to grasp several different core concepts at once. For instance, we're trying to learn the Lua language because without knowing the Lua language, you can't code in JW Lua, which is why we've been spending quite a bit of time with the online Lua editor. Secondly, we're trying to learn good coding practices. Now, we haven't gone into too much detail about good, proper coding practices. And this is really the first video in this series that's going to be talking about that and tackling this topic. But we'll get more onto that later as time goes on. And lastly, we're actually learning JW Lua as well as we go through these videos. Now, each one of these topics, programming, good coding practices, the Lua language, and JW Lua, are all complex enough that really we could create like a 10-hour plus course, paid course for every single one of these, but that's just not worth my time, that's just not worth your time, so I'm trying to pick the most valuable parts for every single one, which is why today we're going over best coding practices. And that's also why there's always so many footnotes at the end. So without further ado, let's look at what good code does, and it's actually very simple. Good code just does two things. One, it's all about readability. Good code is highly readable. You can just look at the code and understand exactly what's going on. Number two, good code is highly editable, meaning you can go in and edit a very little bit of the code and dramatically change the function. Or at least to make any modifications, it doesn't take much effort. Now these two do go hand in hand, like the more editable code is typically more readable, and the more readable code typically is easier to find out where to edit. But we're going to look at some coding examples that are both not readable and not editable. And so here's a couple examples. So now here's two functions, function A and function style expression defs. Now both functions do the exact same thing in JW Lua, but as you can see, the top one is very hard to read, which makes it very hard to edit because you don't know what to change, while the bottom one is a lot easier to read and a lot easier to edit. And even though we haven't really gone over what FC text expression defs does, you can kind of get an idea of what this is, or just the definitions for expression texts. And you can see really simply that we're just defining this, we're loading them all, and then we're looping through each text expression definition and doing some function on it called update fonts and caps. This function you would assume is defined elsewhere, and then afterwards we want to save all of them. It's nice, it's easy to read, and we know that if we want to change the functionality of the style, or if we want to add another thing, like we can even just say fix positioning of TED and add a new function elsewhere, and now we can go through and know exactly what everything is doing. So what's really the difference between these two pieces of code? Well, there's several things. And to explain that, we're going to look over a popular coding problem known as FizzBuzz. Now, FizzBuzz is really simple. It's you just print out all the numbers between 1 and 100. For multiples of 3, you print fizz. For multiples of 5, you print buzz. And for multiples of 3 and 5, you print FizzBuzz. For instance, here is a sample output. You have 1, 2, fizz, because 3 is a multiple of fizz, 4, buzz, and then you keep going on, 14, and then 15 is divisible by both 3 and 5, so it's FizzBuzz. And so let's look at a quick piece of code that accurately describes what's going on here. So before I actually show you any code that fulfills these requirements, first try this on your own with the Lua editor, which I've linked down below, and just see if you can come up with some program that completes all these tasks. Now after you've done that, let's look at my example. So I just have a for loop, nice and simple, that goes from 1 to 100. And if it's divisible by 3 and 5, you print FizzBuzz. If it's divisible by 3 and not 5, remember tilde equals means not, then you just print fizz. If it's equal to 5 and not 3, print buzz. And if it's equal to not 3 and it's not equal to 5, then just print the number. So if we were to run this, we can see it fulfills FizzBuzz perfectly. Now you may have figured out another solution, because one of the reasons why this is actually one of the most popular coding interview questions is that there's many ways to code this out. And oftentimes, the interviewer is just looking to see how you solve a problem and making sure that your code is as readable and editable as possible. Now, if you look at this, you'll notice that there's a couple things in here that make the code, while it's somewhat readable, it's not all that editable. You might say originally that it's actually quite readable, but then you realize to really understand what's going on, you have to read through many lines of code. And it's not editable because let's say we wanted to make it multiples of 4 instead of multiples of 3. Well, then we actually have to go through and change this number many times. And then only after we've changed it 4 times, and then you run it, then we finally have multiples of 4 instead of multiples of 3, but that's a lot of work. So I'm just going to real quickly move this back to multiples of 3, and let's see how we can make this a little bit better. So first of all, instead of having a bunch of if statements and then more if statements and more if statements, we're just going to chain this together in an if then else statement. So we can say if I equals both of those, then print fizzbuzz, and then else if I is equal to 3, and we don't need to check to make sure it's not equal to 5 because we already know it's not equal to both, and print fizz else if, and then we can check to see if it's a multiple of 5, and we don't need to check to see if it's a multiple of 3. Then we can print buzz, and we just say else print I. And then if we run this, we get the exact same output as fizzbuzz, but it's slightly easier to read. Plus, if we wanted to change a number, we just have to change it in 2 locations. So that's one example of how to increase both readability and editability, because as you can see, you don't have to read through nearly as much code to understand what's going on. However, often there's even more to this, because, like I said, we can just add another condition over here. So like, let's say multiples of 7 print zazz instead of just fizzbuzz. So then if we were to take this current solution and add to it, we'd have to add a lot more statements, because we can't simply just add and I modulo 7 equals 0, print fizzbuzz zazz, because now we have to check, or even just that else if I modulo 7 equal to 0, then print zazz. We can't simply stop there, because now we have to figure out all the combinations for fizzbuzz and zazz. And it ends up looking like this. A lot more conditions. Ew. It's like no one wants to read this. And if you want to update this now, it's just messy. Good code is not only just readable and editable, it is readable and continues to be editable the more you edit and read it. So now we're going to look at some specific key concepts we can use that will always help us with editability and readability, which ultimately helps us with good code. So the first one is variable names. So let me give you an example. So we can say local A equals 2, 3, 5, 7, 11, 13, 17, 19, like that, right? So we have this table, nice and simple. We have A equals this table. Now A is not a good variable name, so let's look at real quickly what a good variable name entails. First of all, variable names, the first thing they have to do is describe the content. So they have to describe the contents of the variable name. And the next thing that makes them really good is if they are a standard name if one exists. So let's go through these 2. So first of all, A equals this table. That's not all that good. So perhaps a better way to write this is table. Then we know if we ever see the variable table, we know inside it's a table. But that's not all that great because it still doesn't really describe the contents. Instead, the contents here is a series of numbers. So what's even better than table is to say numbers equals this table. But that's not even the best thing we could possibly do, because this isn't just a table of numbers, it's a table of primes. So the best possible name for this variable is actually primes. And we know that if we were to see primes, the contents would be a table of primes. So let's see how this would work in another way that you can solve fizzbuzz. So here's another way of writing fizzbuzz, and we're going to really see how we can use variable names to make this a lot more descriptive and a lot more readable and a lot more editable. So this time, we're still looping from 1 to 100, but instead of printing out each specific use case, we're going to have a variable named string or str. And then we're simply going to go through all the numbers we want and then just add on to the string whatever term we want. So for instance, at the very beginning, if it's divisible by 3, we say string equals string plus fizz. Now for those of you who don't know, the dot dot means to combine two strings. And the technical term is concatenation. So fizz dot dot buzz becomes fizzbuzz. It's really simple. And then we have another if statement to say if I is divisible by 5, then we take whatever string is, which it may or may not be divisible by 3, we don't know. But whatever it is, we're going to add buzz to it. And then finally, this last statement is where the magic happens. So if string is still empty, so which means it isn't divisible by 3 or divisible by 5, then we want to print the number I. If not, print the string. As you can see, this is a lot better than the chained if-else, if-then statements we've had before. Partly because if we wanted to add Zaz back into this, all we have to do is copy this a little bit, paste it down below, change the number to 7, and add Zaz. Or if we wanted to change any one of these numbers, we just change a single number like that to 4. Which means this code is a lot more editable as well because we've added a variable in. But we can actually go one step further and make it easier to read by changing the variable name. Because the function of this is not just to be a string. Because remember, we want to figure out what the contents is inside of it. So really, this is whatever we're going to output. So output would actually be a better name. And then we can go through all these and replace this with output like that. So this is nice, it is a lot more simple, and it's a lot more editable and still easy to read. However, we can do even better than this. So let's look at yet another way we can make the code easier to read and better. So remember this piece from the very beginning when we said how this is not easy to read? One of the reasons why this is not easy to read to begin with is because we haven't indented. Because remember, indenting is taking code and moving it in like this and starting your code here instead of here, right on the line. So there's a couple ways to know about when to indent, and these are all called code blocks. And there's multiple types of code blocks. We've seen some of them. Some of them are for loops. Others are if statements, and we've seen every time we've used a for loop or an if statement, they indent. And the last one is for functions. Now we haven't really dived into what functions are, and we're going to get to that later in the video. But basically this is an example of a function. And so if we want to indent, this is where we indent, and the code blocks, which are for loops, if statements, and functions. Now how do we indent? Well, indenting is always for spaces. There's some people that will tell you to use 2 spaces or tab or 8 spaces, but the general rule of thumb in the coding community is to always use 4 spaces. In most coding editors, that means you can press tab to indent a little bit. Now realize, what I've done here is actually not really creating a tab character. It is 4 distinct spaces that I've created, because indenting should always be 4 spaces. And why specifically spaces and not tabs? It's because different coding editors display tabs differently. If you always use spaces, it's always going to look the same and it's always going to be readable. So if we were to fix this up and make it more readable with indentation, we see we have a function call, so everything in the function call is indented. And then over here we have a for loop, so everything inside the for loop is indented. Nice and simple. That's just indentation. And if there is an if statement, we would indent for that. Because doesn't this just make it easier to read at a glance? You know exactly the hierarchy of the code going on. And the last thing that we're going to go over is functions. Now, what exactly is a function? A function is a piece of code that you can run in multiple places. For instance, if we have a function called f of x, if we're going to go with math notation, and we're going to say it's going to return 2 times x, and we're going to end the function. Similar syntax to most things we've been doing so far. So now, anytime we want to use this code of return 2 times x, we just call the function. So we say f, parentheses, and insert whatever number we want. Like, I don't know, 2. And that will return 2 times x. And then we can print this, and so if we run this out in the console, we should get 4. And we can, of course, run this multiple times, so print f of 4 should yield us 8. And we can even go print f of negative 2.71828, and it should give us negative 5 point something. Just like that. Now the general form of a function is going to be function. We always start off declaring the function, then we're going to say the name, and we're going to say parameter 1, parameter 2, etc. like that. New line indent. And here we're going to have any code we want to run like that. And we're over here going to return the output. Now the output doesn't really matter, it's just what's going to be the output from the function. And then we use end to end it. And not all functions require an output, some don't. But a function just in general is a way for you to create a flexible piece of code that you can use in multiple places. So like a general rule of thumb in coding is don't type in the same code twice. If you have to type in the same code twice, then there's probably some way you can make it cleaner and better, often with a function. So let's look at another piece of code for FizzBuzz. So over here, we still loop through 1 to 100, we have the string, and then we're just concatenating a bunch of things to the string. And as we can see, this function is a lot easier to read because now we just call another function FizzBuzz test. But instead of having all those if statements, we simply have everything on one line, and we can just copy this line and add another one, like FizzBuzzazz Bazing, like I don't know, something like that. And it always works, and then at the end we just have the general print statement. So this is a lot more readable, and if we really wanted to know what FizzBuzz test is, then we can go over here to this other function. This is called modular coding because whatever you create doesn't have to have every single piece of code in it. You just need to know, what does this one line do? What does this local area of code do? And if there's something like the FizzBuzz test, that you don't really need to know the specifics of how it's implemented, and you just need to know that it works, you can call it here, and then create the function elsewhere. And it just makes things a lot more readable. And the other really nice thing about functions is we can actually make this a lot more flexible in general. So instead of just having this random piece of code here, we're going to add a function. And we're going to call it FizzBuzz because, well, we're creating FizzBuzz. And we're going to have a first, a last, and an increment. Like this. And of course, always end the function and indent everything like that. And so here we're going to have the first, last, and increment, which this makes the function a lot more flexible because then we could just say FizzBuzz of 1 to 100 by 1s. Okay, and then we can say print FizzBuzz of 1 to 100, increment by 1, and then have that on one line. Or we can do it multiple times because we don't need to copy the code now, we have a function. And you can say 1 to 100 by 2s, or 100 by 12s, or 1 to 1,000. Or we can even go in reverse, from 100 to 1 by -1s. Everything is possible now that we've wrapped it into a function, which means now we can simply declare FizzBuzz, and it's really simple to use, really easy to edit because we just literally edit these numbers down here. We don't care about the implementation. And if we do need to edit the implementation, we just go over here and edit the implementation. And it's incredibly readable because when you look at this, you know exactly what's going on. And so that is the basics of what good code is with readability and editability. So again, we talked about variable naming, making sure the names describe the contents of the variable, or if they're a standard name, like often we'll use the variable I in for loops, that's a standard name, you use that as to not confuse people. We talked about indenting, which is always 4 spaces, not tabs, not 2 spaces, not 8 spaces, always 4 spaces. And last time we introduced you to functions, that we can actually create more modular code that's easy to read, easier to edit, and a lot more flexible, and allows you to get rid of duplicate code. So what's next? Well, next is going to be homework, but there's a couple of things I want to point out, because this implementation is still not ideal, because we still have all of this duplicate code. Now, ordinarily, this isn't bad, until you realize that in the future, you may have this as your entire log of code. And if you want to find the one thing you need to edit in all of this code, that can be really challenging and really tough, and it's not readable. Because we see FizzBuzz, we see a bunch of yada yada yada, I don't know, and then all the way down here on the next page, we have the actual output for the function. And so that's going to be part of your homework, but to build up to that, here's a couple things to do to get used to writing good code. So first of all, we created a function in the past that basically went from 1 to 50 and did 2 to the power of I, whatever that is. So we can print 0, 1, 2, 4, 8, 16, 32, 64, etc. And most of you probably came up with a for loop that looked very similar to this. So now, for the first homework assignment, which should be decently simple if you've been following along, is we're just going to turn this into a function. So edit this code to create a function that does the exact same thing with arguments of start, end, and power. So perhaps instead of 3 to the I, we want 4 to the I, or 5 to the I, or 6 to the I, or go from 2 to 20 million, or 1 to 3 instead of 1 to 50, or whatever. And as you do this, remember as many of the best coding practices we've gone over so far. Then, here's a more complicated solution, but will really require you to use functions and to write good, clean, editable code, is to calculate taxes. So in the US, we have different tax brackets that tax your income at different rates. We're not going to use the actual US tax brackets because there's a lot, but we're going to use these ones just to keep it nice and simple and straightforward. And the important thing with these tax brackets is that when you go up to a higher tax bracket, not all of your income is taxed at that higher level. Only the income in the new tax bracket is taxed at that income. For instance, if you make $15,000 a year, $10,000 of those dollars are not taxed, and another $5,000, because they're in the upper tax bracket, get taxed at 15%. So if you make $121,000 a year, you pay $3,239.55 in taxes, which is $10,000 times 0%, $19,999 times 15%, $69,999 times 30% for this tax bracket, and finally, $21,000, which is the remaining over $100,000 times the higher tax bracket, gets you this. So what you're going to do is you're going to write a function which accepts the annual income and returns the amount of taxes owed. So that should be your step 1. Ultimately, it's not going to be the most highly editable code, but once you do it, you'll have a better idea of what you're doing. And finally, once you do that, make it as editable as possible, because every year the IRS likes to update its new tax brackets, often because inflation increases or sometimes other different measures, like there might be a new bill that's passed. But we don't know exactly how they're going to do that in the future, so you want to make sure this is as editable as possible. The third one is we're going to fix FizzBuzz like we worked on before. So the first thing you're going to do is eliminate that redundant code. That's all this redundant code. Eliminate that. Use optional arguments. See the footnote on optional arguments. Basically what that allows you to do is over here, we still had the increment, but what if we wanted a default increment of 1 and just leave out that parameter? What would we do? That's an optional argument, and we're going to see how that works. And thirdly, make sure that you can add new words in the function call. This will require the use of tables and optional arguments to really make sure this works well. And that means if you do this right, simply from the function call down here, you can have the default FizzBuzz, you can have FizzBuzz from custom ranges, you can have custom increments, and you can have custom FizzBuzz, Zazbzing, Bazong, Bazoodles, or whatever you want to say. Or you can have nothing in the middle and just run normal FizzBuzz. That is the challenge for this question. And lastly, just for fun, you're going to write the worst possible FizzBuzz. It should still work properly, but it should be entirely uneditable, unreadable, and incredibly creative however you do it. And yes, this is actually not an absurd question. This is another standard interview question if you're going into coding. And so the question you might have is, why are we spending so much time on FizzBuzz when we don't even want to become professional coders? It's because these concepts of good coding practice are actually really simple, really easy, and most people don't follow them. But if you have amazing, spectacular code, it becomes really easy to edit and work with. And especially with JW Lua, where as time goes on, more and more people are going to be sharing their scripts, more and more people are going to be referencing each other's scripts and bouncing ideas off each other. It's already happened with scripts and some of my colleagues have worked on. We've been passing back and forth scripts and getting new ideas based on what other people have found and coded. That is only possible with good written code. So to help you along with this, here's just a brief rundown of the homework. Again, recode the for loop, calculate the taxes, fix FizzBuzz, and utterly break FizzBuzz to your heart's desire. And on top of that, we're going to have some footnotes. They're going to be nice and simple. So first of all, why do I use output and not output string? That may be a question you're asking yourself, because output string is more specific than output. And it even tells you what the data type is, but typically you want to use output and not output string. Now, the next thing is everything you need to know about functions, sort of. This is just everything you need to know at this stage. There's a lot more you can do with functions. But realistically, in this video series, we're not going to cover most of them. And if we do, it'll be in another footnote later on when we need it. Then you're going to learn about optional arguments. Again, this is suggested with the second coding question for the IRS, and basically mandatory for the third homework question with FizzBuzz. So this is a video to definitely watch. Then we're going to look over different types of comments, because as you may have been noticing, I've been using mainly the dash dash comment for a lot of these. I've just been using dash dash comment and this code doesn't run, but there's other types of comments, and they can be really useful as you're coding and debugging things. And lastly, despite all this emphasis on comments, we're going to talk about why you should never use comments in production code, or any code really that you send off to anyone ever or work on. In other words, why you should only use comments for debugging purposes and nothing else. So that's it for next week. Next week, we're going to go over octave transpositions and how to do that in JW Lua. But more specifically, and the more exciting thing about next week, is we're going to learn exactly how I've been able to figure out what these different functions and method calls are in JW Lua, like what we were talking about with the text expression defs, or how I knew to calculate the highest MIDI note or to change a note head. How exactly did I know what to write there? We're going to go over the class browser, and it's going to be detailed, and it's going to be thorough, and it's going to be the kind of thing you can only learn after watching this video. So make sure to hit the subscribe button and ring the bell so you know as soon as JW Lua number 5 comes out. And in the meantime, post your answers to the homework below. I will read every single answer you put there, and I will help you out as much as I possibly can.